So when I'm doing that, I split it into sections and do multiples. So I know that this is 2 pi. So I'm looking at a radian measure of 360. Half of that, so I full circle is 2 pi. Half of that would be pi halves. Half of that would be pi fourths. And so that's how I can get these measure, and pi fourths is the same thing as 45 or degrees. And so I can use that for my multiples. So this is pi fourths, pi halves, 3 pi fourths. And so if you want to add your pi fourths, 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths right here, 6 pi fourths, which reduces to 3 pi halves. And then we get 7 pi fourths, and then 8 pi fourths, which is 2 pi. And so then we can do the same thing if we take this pi halves and we split it into 3 equal chunks. So this is really like 90 degrees. If I split 90 degrees into 3 equal chunks, I'm getting the 30 degrees. But what's that in a radian measure? If I take pi halves, and I multiply that, one third of pi halves splitting into 3 sections, you get pi 6. So this is how you can always find this measure if you forget it. So this is pi 6. Then I do multiples of pi 6. So this is 1 pi 6. This is 2 pi 6, which is pi thirds. 3 pi 6, which is 1 half. 4 pi 6, which is 2 pi thirds. 5 pi 6, 6 pi 6, 7 pi 6. So I'm just doing multiples as I go in the circle. 8 pi 6, which is 4 pi thirds, 9 pi 6, 10 pi 6, and 11 pi 6. So I can go all the way around the circle, and I can reduce these to find our radian measures as we go around the circle. So at all of these radian measures, these all create these right triangles. We have, this is a 30, 60, 90 right triangle. The next one is a 45, 45, 90. And then this last one is a 60, then 30. So the 30, 60, it gets flipped on the measures. This one's now 30 and this one's 60. And so when we're looking at what our x and y values, really what we're going to be trying to find here is what are the x value of this triangle and what is the y value of the triangle. What's the x and the y for that? That goes back to our special right triangle. So if I look at my 30, 60, 90 right triangle, I know that y value here is 1 half. I know that my long leg is a square root of 3 over 2. So this point at this pi 6 is going to be my x value, which is root 3 over 2, comma 1 half. And so I can use my special right triangles to find these points. This is going to be root 2 over 2, root 2 over 2. This is the 45, 45. And then the 30, 60, 90 flipped around, this point just becomes flipped. And so it becomes 1 half. This point right here is 1 half, comma, root 3 over 2. And so we can find the points for all of these degrees by just finding what is the right triangle that is made at that radian measure. So we're talking more about that in the future, but I want to introduce the unit circle and how to find those values. So we have our trig functions here. Trig functions, the same. SOHCAHTOA. You should recall that from geometry. Sine of t. Sine is the opposite divided by the hypotenuse. That's what that saying helps us out with. So sine of some angle. Sine is talking about the ratio for, at this angle, what's the ratio of the opposite side divided by the hypotenuse side. So we have to understand labeling. So we have some angle. We have some angle here, t. Then it creates some kind of triangle here, where if we have this angle t, the side across from it is called the opposite. The hypotenuse is always opposite the right angle, and then the other side we call the adjacent, the one that's next to the angle that's not the hypotenuse. We have to understand how to label the 3 sides of a right triangle. And so then we have the cosine of t, which is the adjacent divided by the hypotenuse. So we take that, those 2 lengths, you divide them, that is the ratio for the cosine of t. Those are equivalent. So the tangent of t is the opposite over adjacent. Now we have three more, and these are just the reciprocals of the one on the left. Sine and cosecant are reciprocals, so I can just flip them. So hypotenuse over opposite. Secant is a reciprocal of cosine, so that's going to be hypotenuse over adjacent. And then cotangent is reciprocal of tangent, so it's adjacent over opposite. So these are the 6 trig functions we're going to talk about. And so, example, a trig functions if t is a real number describing an arc length from 1, 0, and xy is a point on a unit circle. So we're going to apply it to the unit circle, pretty much all it's the same. We have our point xy, and we have our circle, where we know that our radius here creates the value 1, from 1, 0, so that's the point 1, and so our radius is 1. So then if we drop the point right here straight down, we're going to create an x and a y value. So this is the angle t we're looking at for this triangle, and so we have a y value and an x value. So the sine of that triangle is the opposite over hypotenuse. So if you need to label that triangle first and say, okay, what is the hypotenuse? It's going to be r. What is the opposite? That's y. What is the adjacent? That is x. And I can use those 3 values just to write our 6 trig functions. Sine is going to be opposite over our hypotenuse, y over r. Cosine is adjacent over hypotenuse r. Tangent is our opposite y over our adjacent x. Cosecant is reciprocal of sine, so it's going to be r over y. Secant is going to be r over x. And then cotangent is going to be x over y. So that's how you can write those. But for this example, we know what our r is. Our r has to equal 1. It's a unit circle. So we know that the sine of t is just y. Cosine of t is x. The tangent of t is still y over x. So we don't have the r value. Cosecant is just going to be 1 over y. And you might be able to rationalize that if y is a root. Secant is going to be 1 over x. Cotangent is still x over y. Why is this important? Is because of those points we just found, when you wrote those points down here, whatever your x value is and then your y value is for the unit circle, we know the x value is describing the cosine of t and the y value is describing the sine of t. So if we go back and look at the unit circle, when we wrote this point right here, that point was the square root of 3 over 2 comma 1/2. And so then we know, as the sine is the y over r and r is 1, that this is really the sine. And this is really the cosine. So all of these points are giving us the cosine and the sine at the angle measure. So at 30 degrees, I know the cosine is root 3 over 2. I know the sine is 1/2. At the sine of 30 degrees and the cosine of 30 degrees. So I'm hoping you start connecting all these pieces together for the unit circle. There's a lot to get there. So we can find all the 6 trig functions for t equal 2 pi thirds. So I'm going to do some of this. You're going to do the others for homework video problem. Let's first plot the origin and the initial ray. We need to figure out where 2 pi thirds is. So this is going to be 2 pi all the way around, 0 or 2 pi all the way around. This is still pi. So if I go half of that, this is pi halves, which all the equivalency is the same thing as like 2 pi fourths or 3 pi sixths. And so I may use the 6, 3 pi 6 equivalent, because 2 pi thirds is 4 pi 6. And so it's past it. So I know that I'm up here. I can also know that by thirds. I'm splitting, if I split pi in thirds, 1, 2 pi thirds. And so I know my angle I'm looking at is right here. This is 2 pi thirds. So then I need to figure out what I'm looking at here. And so if I take at this point, I go straight down and then right. What is this angle measure? Not the 2 pi thirds, what's left over at the pi. This is only pi thirds left over. Pi thirds is 60 degrees. So this has to be 30 degrees. This is our right angle. And so you need to be able to find this right triangle, because once you find that, then we can label what the point is. knowing that our radius is 1, then we know that the short leg, which is always across from a 30, has to be 1/2, and the long leg is √3/2. And so the importance of having this, now I know this point. This point is x comma y, which is 1/2, and then √3/2. That's this point. That point then gives us an x and a y value, which helps us find the 6 trig functions. So we have the sine of t, cosine t, tangent t, and then the cosecant, secant, and cotangent are just reciprocals of what we just wrote. And we want to rationalize those when possible. So I'm going to do one, and I'm going to have you actually do the rest. So the sine of t, again, we're looking at the angle here, which is going to be the same as the angle here, 2π3. And so for this measure is opposite over hypotenuse, which is just going to be √3/2/1, or it's just our y value from the previous slide. So our sine value is just going to be the √3/2. That is the sine. It's just the y value is our sine. And that's what we're talking about in the previous slide. Now, there's one more thing I want to talk about before I let you finish up the problem, is that we have to think about, we're talking about the y value here. Our y value here is positive because we're above the x-axis. Think about what that would be. And so there's a saying I have here. Our sines are above the y-axis, or our sines are positive. Below the y-axis, our sines are going to be negative. So the saying that all students take calc. And what this is saying here is that this is where each function is positive. So the sine is positive in this quadrant, the cosine is positive in this quadrant, the tangent is positive in this quadrant, all of them are positive in this quadrant. The other spots are going to be negative. So where your point is should tell you which of these 6 trig functions are going to be positive and negative. So when you write these, be careful about which ones are positive and negative. And so you look at your cosine, I kind of give you a heads up. Your cosine, we're in the second quadrant, so our cosine is going to be negative in that quadrant. So see how well you can do writing the other 5 trig functions for this point. I've done kind of the setup for you. You just need to evaluate it. So a couple more things. Periodic functions. Function f is periodic if there's a positive real number c such that the trig function f of t plus c is equal f of t. So if you add c to it, you get the same as the original function. It's periodic. You've come back to the original answer. The period of f is the smallest value of c such that those two are still equivalent. So we're just saying the same thing, that f of t plus c has to equal f of t. So what's that smallest value it could be? So example of that, the example of sine of 9π/3, which would be the example of same thing as sine of 3π. And so I can take away 2π because every 2π is equivalent. So this is the same thing as sine pi. So this would be the smallest period pi. And so what is the sine of pi? On a unit circle, pi is over here, sines are y value, so that have a value of 0. So we can evaluate that, so we can get down to the smallest period, which will help us find out in the unit circle. Okay, even odd functions, and we'll learn more about this when we start graphing it. It looks at the negative value, the negative angle. So the sine of negative t is equal to the negative sine t. Tangent of negative t is equal to the negative tangent t. The reciprocals have the same one, so cosecant of negative t is equal to negative cosecant t, and cotangent of negative t is equal to negative cotangent t. These are all considered odd, and if you're even and odd from back in chapter 1, this is following that same definition. The other ones are even, only 2 more left, and these are the ones we use more often. Cosine of a negative t is just cosine t, and the secant of a negative t is equal to the secant t. You plug in the negative value, you still get the positive function back. The negative angle gives us the same as the positive angle. And so those are some properties or identities that we're going to use to help us simplify some. So that is it for 4.1 and 4.2. So